Welcome back to React Native Radio Podcast. Brought to you by Comcast Cable. Comcast. Why the rush? Relax. Enjoy the extra break. Episode 217. Performance Enhancing Drugs for your React Native app, Part 1.
So did either of you order the new MacBook? The one like with a M1 Max CPU?
I did. I'm getting it in like 2 weeks. I'm really excited.
In 2 weeks? How'd you pull that off? I ordered it and it's not coming till December.
Because I ordered it like immediately when it was released. Like I was on the store and I ordered it and I'm like, this is my new Mac. I've been struggling along with this 5-year-old MacBook Pro i9 and it's not enough for me anymore. So I'm very excited about getting it.
Struggling with an i9. Yeah, that's where we are right now. I deliberated for longer. Besides, I was having problems like loading the store. It was like timing out and stuff. So I waited a whole day. And by that time it had stretched out into either mid-November to December, basically. You could pay an extra $8 to get it like 1 day earlier, but it was still like a 2-week span. I have a 2019 MacBook Pro and it has an i9 and it's like, this is a very cool computer. I love it. It's great. It has a touch bar. It has, Touch ID.
Rest in peace.
Yes, rest in peace. Exactly. That touch bar is no more. I had to get this though, because I'm doing streaming now, as you all know, twitch.tv/JaminHolmgren. Little plug there. And I can't open like Android Studio and Xcode at the same time. Like it just bogs down the computer. I can't stream at the same time as doing all that. So yeah, I ordered it. I'm really excited. Can't wait for it to come. And you're gonna have to tell me how awesome it is, Mark, so I can just be extremely envious.
Yeah, it's going to be a huge upgrade for me. 5 years has been what I usually keep my computers for, but we're getting a little long in the tooth. So I'm very excited for the extra speed boost of the new M1 Max chip. Speaking
of speed boost, that is our topic for today. We're going to be talking about performance. But before I do that, I'm going to go ahead and introduce who I'm talking to here. Of course, I'm Jamin Holmgren. I am the host of React Native Radio, co-founder and CTO of Infinite Red, and I don't know, what else? I guess I'm a software developer of 16 years professionally. I've been doing it since I was 12. So also the gentleman who has been talking here is Mark Rickert. Mark is on the program today to kind of give us some more, I guess, expertise in this topic because he's been doing a lot of work on the performance side of things. Mark is a principal software engineer here at Infinite Red. Mark and I have known each other for a long time, and he was even on the program before. He was, I think it was React Native Radio 204, talking about dependencies back then. So if you've listened to the program since we took it over, you've heard Mark before. Mark lives over in Asheville, North Carolina, but you're moving soon, right, Mark?
Yeah, that's right. I'm going back to Moab, Utah. That's where my heart is.
Yeah, I mean, when you've talked about Moab, it has always been like, this is where you want to be. It's the type of place you like. And you actually have a house over there, right?
Yeah, I bought a house there and lived in it for about a year and a half. And then my girlfriend got a job in North Carolina. So I'm in North Carolina now, but we're going back.
Yeah, that's awesome. It'll be great to have you back there. And also with me is John Major Condon. John Major lives in Janesville, Wisconsin, senior software engineer here at Infinite Red, edits the React Native newsletter, does not have a MacBook Pro M1 Max coming, unfortunately.
No, unfortunately not.
Shame.
All of my money's wrapped up in Shiba Inu.
Well, maybe if Shiba does well, you can afford one.
I've been making a lot of money on Shiba.
There you go.
Yeah.
I bought I won't say how much. I bought a bunch of Shiba, and then when it spiked up, I sold what I bought it for, like the amount that I put into it, and I still have a bunch left. So it's like free money, right?
Nice.
Free money.
Mazen is not here for this episode, but we are doing a part 1 of part 2. So hopefully he'll be back for part 2. And we're going to go ahead and talk with Mark again about performance because we have so much to talk about here.
Yeah, it's a big topic.
It really is. It really is. So let's roll forward into the topic. This episode is sponsored by Infinite Red. We are a premier React Native design and development agency located fully remote in the US and Canada, and soon to be Moab, Utah, I guess. If you're looking for React Native expertise for your next React Native project, hit us up. You can learn more on our website, infinite.red/React Native, and don't forget to mention that you heard about us through the React Native Radio podcast. And if you're a senior level React Native engineer located in the US or Canada, we are hiring. Go to careers.infinite.red and submit the form. All right, let's get into the topic for today. The title is slightly provocative. It is Performance Enhancing Drugs for Your React Native App with Mark Rickert. And this is part 1 of part 2. And we're going to be talking more in part 2 about some other, well, we just have so much to talk about. So first off, I'd like to talk about React Native performance in general. This is a frequent question that pops up when people are introduced to React Native. It seems weird. Like I even had this question when I first heard about it. I'm like, JavaScript? Oh, you're talking about PhoneGap or Cordova, right? No, we're not. But you are running JavaScript, like an on-device engine, either JavaScript Core or Hermes, and you're talking over a bridge, which means you're serializing stuff and sending it to native, and then that...
Serializing with JSON, which is not fast.
Exactly, and so it's like text. It's a big string that goes across, and then it comes back as text as well. It has to be serialized and deserialized 4 times just to make one call, right? Mm-hmm. And so that does seem like it'll be slow, and it can be, but that's also not the full story. You know, there's a lot more to performance than just that. There's no silver bullet for performance. You can't just flip a performance switch and then all of a sudden it's fast. Do either of you remember the turbo button on like old 486 computers?
Oh yeah. That thing was permanently on my machines. Just press it and everything just gets faster.
No, but you are making me think about the shoes where you can, they're like basketball shoes and they have like a basketball logo on it and you press it to like pump up.
The pumps.
Yep, exactly. Yes.
Pumps.
Nike pumps from back in the day.
Oh man, those are such a big deal when they came out. I think I was in middle school or something. Mark and I are the same age, so we probably remember the exact same thing. I'm sure I had knockoffs. They weren't Nikes. But yeah, no, that's totally... the only time I would turn off the turbo is if I ran a game that was not... Like most of the games back then were not like set up for different timings. They would be like optimized for a certain computer. And if you had a faster computer... You had to turn off turbo to make the game playable or else it'd just go too fast. You couldn't, the clock speed was too fast. We don't have that, unfortunately.
No.
We can't just do that. Although I will say when the new architecture arrives, that may be like a turbo button, but we'll be talking more about that later. But yeah, let's I don't know. What do you guys think about React Native performance in general?
Yeah, I think in general, React and by default, then React Native is pretty performant. Like if you're writing a personal app or a small app, like you probably don't need to do a lot of the things we're talking about today. But if you've got something that's hundreds of files and 150 different components, and just like a very complex React application, you're likely going to be coming into performance issues. Like React is fast in general, but once you start adding computations in there, data transformations, calculating really large data sets and mapping over them, that's when JavaScript can block the main thread and cause your UI to just slow to an actual crawl. But I'd like to point out something that Donald Knuth, I think that's his last name. He's a Stanford computer scientist, and he wrote it's like a series of books called The Art of Computer Programming. And he said, pre-optimization is the root of all evil. And so I would say that you should do optimization when you find something that's taking too long. Don't just optimize things before you've even tested them, because it could be that, yeah, it might be best practice to wrap a function in a use callback hook, but it might actually take more overhead to create that callback than to actually just re-render the function every single time. So, but we'll get more into that here soon. I think today we're going to talk about things that we can just keep in mind as you're developing to write the most performant code possible. And then later we're going to talk a little bit about performance tools that we can use to measure, which is always great when you're talking to a client. You're like, I sped it up by 212%. They're like, how do you know? And it's because I profiled it. Like I ran the app in the exact same situation on 2 branches. and it told me exactly how much speed I gained. So yeah.
Yeah, and of course, like all of these statistics can sort of be misleading if they're in the wrong, kind of vector. Because like, what is performance in terms of a mobile app? It's, is it more straight line speed, or is it perceived performance? So, for example, if you have like a back end app, let's say on like a server, or it can even be on a mobile app, you don't really care. Let's say that actually, let me go this direction. Let's say you're mining Shiba on your on your mobile app, and it's going in the background, right? You don't really care if it stutters and stops and stuff like that, as long as the overall output is more Shiba, right? And you can measure that by Shiba per hour, right?
Right. Right.
And however, if you have an app that works extremely fast, but every 1 second it pauses for like a tenth of a second. Every second you have a tenth of it, or every 10 seconds or whatever, you have a tenth of a second. People are going to get very frustrated, even though the extreme speed in the middle is, you're not looking for total output. You want smoothness. You want things to be smooth and feel buttery.
Right. Nobody likes a stuttery scroll view.
Yeah, exactly. So is like faster always better?
Well, so faster, I think, is always better, but sometimes it just can't be faster. Like your server takes a long time to respond to a query or something like that. That's the server team's job to make that feel faster. But in that case, what you can do is try to make it feel faster with some techniques like making sure the user understands that there's something going on, instead of just like waiting for the response to come back. Let the user know with a spinner or a pull to refresh or some indication that something is actually happening. Because if a user doesn't see anything happening and doesn't see the data they want on your screen, they're going to think something's slow.
Yeah, and there's even situations where showing a spinner can make it feel slower. So like, you have to really think about it. Like, if you always show a spinner immediately, people are going to be like, oh, there was a delay, where they may not have noticed it otherwise. So it's very situational, isn't it?
Exactly. Yeah. And there's a couple things to take into consideration, especially when we're talking about React Native app performance, right? We've got boot time. How long does it take for your app's native loading screen to disappear and for React Native to start doing its job, right? And the way you increase that is like optimizing your native code. And that's not really what we're here to talk to about. So I think we're going to be talking mostly about things after boot time, what we can do to increase our what's called time to interaction, which is how long it takes for your navigation stack and home component to render. Like if you've got a tab bar and users can return back to a different tab, it depends on the home component on that tab as to how fast it loads when it re-renders. So there's quite a few things to take into account when we're talking about React Native performance.
Going back to boot time for just a second, one of the things that will help a lot with that will be turbo modules, because instead of loading all of the native modules immediately before it kicks off the JavaScript side, it will actually load them only when needed. So it'll be sort of lazy loading for native modules. Turbo modules is going to help a lot with the boot time if you have a lot of like native modules that are slowing things down. So that is a note to make.
Yeah, definitely. Another thing that is going to improve your performance is getting rid of your console log statements. If you've ever had a console log in a big loop or in the render function of your component and it just runs all the time, like just removing some console log statements is going to increase the performance of the app, because those are huge performance killers. We all know that there's a Babel transform plugin, right, for React Native that when you actually go to release in production mode, it'll strip out all the console.log statements and all the dev statements and stuff like that. So definitely running in production mode, you're going to get a lot better feel for how fast and smooth your application is, especially if you have a lot of console logs going back and forth over that little wire connecting your device to your terminal.
Yeah.
And definitely check for other Babel plugins that do clean up things such as like test IDs, and then also optimizing images and so forth. There's a lot out there.
Yeah. Well, I think we're going to get into images here in a little bit.
That is true.
Yeah, totally. So like, the first place I usually go when I'm looking for topics like this would be the documentation. And they do have a performance section of the React Native documentation.
Yeah, the React Native docs are really great for kind of giving you an idea of how something should be done. And when you're working in a language like this, you spend a lot of time working with libraries and components you didn't write. You're using other people's modules. You should read the manual for everything, RTFM everything. And that's what's going to get you into a mindset of how do I make this thing the best it can be, instead of just like starting typing and relying on IntelliSense to give you the properties you think you might need. I spend a lot of time in the documentation for libraries and for React and just researching and stuff like that. But there's also TypeScript definition files that I use VS Code, and I can just hit Command and click on the thing, and it'll open the TypeScript definition file, and I can scroll through and see a list of every single property that this can have. And generally, good library maintainers will have inline comments on those TypeScript files that give you the documentation for it. So TypeScript is definitely a really great way to make sure that you know what these components can do that you didn't write.
Yeah, totally. And if you go through the React Native performance docs themselves, the page that I was referring to, we will put this in the show notes, by the way. One of the things they mention is 60 FPS frames, and there is the famous 16.67 milliseconds number. And I know you guys know this already, but I'm going to explain for our listeners what the 16.67 milliseconds is all about. If you take 60 frames per second and you divide that by the number of milliseconds, you're going to get 16.67 milliseconds per frame. So you need to do all of your work, everything you need, everything that has to happen. You have a budget of 16.67 milliseconds if you want to get done before the next frame. Because if you don't, you're going to drop a frame and it's going to stutter. You're going to feel that. It's like, oh, I missed something. Like there's a little jerk in the scrolling as it happens, or the animation or whatever.
Yeah, and React Native actually has a tool to help you with this. And I'm going to put you on the spot here, John Major. Have you ever opened the React Native performance monitor?
You know what? On native, no, I have not.
Okay.
And I honestly think because React Native is already just performant for me already. When it comes to React.js, though, working on bigger projects on the web, I have many times, and it is a lifesaver.
It definitely is. And it's actually really easy to get to in your React Native app once you've built it and you're running it on the simulator or on your device. It works great on Android and iOS. You just shake it, bring up the dev menu, and there's a enable or disable performance monitor option in there. And that'll put a little floating window on top of your React Native application that'll show you your FPS and memory usage and stuff like that. And it actually shows a little bit more info on Android, like number of dropped frames and stuff like that it doesn't show on iOS. But you can click and drag that around your window. It's kind of annoying, though, that it's on top of everything. And it always starts in the upper left-hand corner, so you always got to drag it around. But that's how you get it open, and I work with that on almost all the time. But that's because I'm mostly doing performance enhancements right now.
Yeah, and it's showing 2 frames per second numbers. Can you explain what those are all about, Mark?
Yeah, so the UI frame rate is how fast the application's native UI is updating. And then the JavaScript frame rate is how fast the JavaScript main thread loop is running. And so your actual JavaScript FPS monitor might freeze if you lock the main thread for a while. If you're doing some heavy computations or something like that, it could say 60 frames a second, but your app just doesn't respond. And then like 2 seconds later, you'll get the graph will update itself and you'll see that it was 0 FPS.
Yeah, and those 2 numbers are connected, but also decoupled to some extent. So you could, for example, be in a situation where you have a native component like a scroll view, and or it has a native part to it, and the scroll goes up and down just fine. It's buttery smooth, but your JavaScript side of things is doing something else, and so it's like not catching up. And we've run into this before where you're scrolling and you're wanting these on scroll events to happen, but they're only happening like every second, and you want it to happen like every a lot more often than that, right? And so you're not catching the scroll very often. And that really comes into effect when you're trying to make something animate during a scroll or something like that. So you have to be thinking about both sides of the equation, the JavaScript thread as well as the main UI thread.
Yeah, and if you're doing some heavy computation on that on-scroll event there, you should also add a scroll throttle to the scroll view. There's a property where it will limit how often that function callback fires.
If you don't need to do that every single scroll event, you can just, if it's something kind of like just not as necessary. I think this is kind of a common theme. So like way back in the QBasic days when I used to make little games and stuff, I even understood this. And I would do things like, let's say you're calculating a path, right? To like a little character needs to walk through a path, right? You don't need to calculate that every single frame. You don't need to go back and like run that pathfinding algorithm every single frame. You can just save the result of the pathfinding algorithm, and then the character can kind of just walk along. And then if it encounters something new that it didn't see before, like someone walks in its way, then it can be like, hey, I need a new path. And it just calls it again. Or you can do it like every 10 steps or every 60 steps or something like that. So you're not just constantly recalculating and doing stuff like that.
So this seems like a request animation frame. How does this differ from that?
So request animation frame is a great tool that we have. And what that allows us to do is say, after the next frame hits, I want to run this. So it's like, I know that I'm kind of exceeding my budget right now. I'm getting close to that where I'm going to start dropping frames. Let's put that into the next one, request animation frame. And so that callback that you get there is really helpful for that. We're going to be talking more about this as we get into part 2 specifically about request animation frame, but that's definitely an awesome tool in our toolbox.
A little teaser there for part 2.
Exactly. You gotta tune in next week. So I actually wrote a tweet a while back and I said, one of my developers just messaged me. That was Mark, by the way. The performance improvement in the React Native app after this fix was like, knock your socks off better. And then I wrote, the ironic thing, it was some native code, Objective-C, that was causing memory leaks and performance problems.
Yeah, we're dealing with a much more complex ecosystem here than just native developers have to deal with. We have to know JavaScript, we have to know React, we have to know TypeScript usually, Objective-C or Swift and Java and Kotlin. So there's like a whole bunch of things that we need to be able to know and understand how they work together in this ecosystem. I think a React Native developer should at least know a little bit of everything there. Java, Objective-C, definitely a lot of JavaScript. but yeah, having such a complex ecosystem means that bugs might not always come from where you expect them to be.
Yeah, so explain a little bit more about that particular problem. It was like an ad banner that was getting allocated, and basically it was a memory leak. They kept allocating more and more, right?
Yeah. It was a memory leak in a custom component. The issue you have sometimes with React Native projects is you get all kinds of developers coming into it. They're like, you got web developers coming in, you got Swift developers coming in, you got Android developers coming in, and they might not know all the best practices and they might not know about memory management and how it's a much bigger deal in Objective-C, which this code was written in. And essentially it was just a memory leak where we were dereferencing a value and not removing its delegate. So we were just holding on to that reference.
Yeah, there's a reference to this pretty heavy, honestly, native component. And so it was just piling up everything. I don't know if it was like every time you'd scroll or something like that, it would just pile up more and more. And everybody's like, why is this thing so slow? Mark comes in there and like, you figured this out later.
Oh man, it took me a long time to find this one.
Yeah.
Like I would just watch the memory usage of the app grow and grow and grow and grow until it finally crashed after, 20, 30 minutes of extreme usage. And, yeah, I knew it had to be some kind of memory leak in the native side of it. So I literally just went looking and I just started reading code and this one little thing popped out to me in my mind after about 2 weeks on and off of this task. Like trying to figure it out, wondering where it was. And so sometimes these can be very frustrating bugs but once I fixed it, the performance in the app was again, knock your socks off better.
So for our listeners that don't have native experience, is there something in the short term that could be done on the JS side to help with some or most performance issues?
Well, yeah, absolutely. If you find that something's jittery or taking too long to load or is killing the JavaScript frame rate or something like that, you should start using the profiling tools that are available to you. There's things like Flipper and the React DevTools library and Reactatron that can help you with profiling your application. And generally what I'll do is I'll just fire it up and reload the application and profile as soon as I'm allowed to in the boot sequence. And then once the app boots up, stop the profiling and then just look at the React profiler, and you'll be able to see which frames were taking longer to render. And then you can dig into which components and which functions and stuff like that really just took longer than you wanted them to take. And so you can do a sort of like a targeted strike on your code base for the things that are taking the longest and are slowing down your boot sequence or slowing down your renders. Another thing you can do is move data computation into your data store. We use MobX State Tree at Infinite Red, and they have this idea of computed values using getters. And so anything that can be stored in the model should be, and you should just reference that computed value.
So, Mark, I want to put you on the spot like you did with me. So in Slack, I remember you had messaged a pretty cool performance improvement, and that was something to deal with section list. And I want to, I guess, have you kind of explain what those two lines were that fixed the problem for you.
You'll have to remind me. Did it have to do with like initial number of items to render?
Yep, max to render per batch.
Because max to render per batch, exactly. Yeah, so React Native actually has a specific page in their docs for performance improvements on virtualized lists, so section list and flat list. And there are a lot of default values that a lot of people don't use or know about, and it can really help, especially if you are rendering very complex things. React Native tries to make section lists as fast as possible, but they have to rely on defaults. And so they just kind of guess at how many things that they should render at one time, and they render things in batches. And so you can say, okay, the next batch of renders, I only want it to render 3 items instead of 10 items. And so that will speed up that next render cycle at the expense of having to render more often. So that's something where you can do with virtualized lists in React Native that will really help increase your performance. Do you know that when you're scrolling in a virtualized list, I think it keeps like 20 pages. So, or maybe 21 pages. I think it's 10 above the window, 10 below the window, and then the page that's in the window with all the items. So, digging into how the virtualized list component can provide you with these sorts of options to customize how your list renders is going to really be a big benefit for you in terms of performance.
Mark, you have a note here about avoiding anonymous functions. I don't think this is necessarily a performance enhancement by itself, but it helps you track down performance problems, right?
Yeah, exactly. So if you fire up the performance tools in Flipper, let's say, it's going to tell you how long each view and component and everything rendered in a big, I think they call it a flame graph.
Yeah, this is similar to what's in React.js and the DevTools, where you have that flame graph. Or I'm sorry, this is actually Chrome DevTools. And that flame graph, I remember seeing anonymous functions left and right on projects that I've entered in on and trying to track down what those functions are.
Right, because obviously the anonymous functions don't tell you where they are. They just tell you what their parent is, which is usually the main component that's rendering. And so if you pull all those anonymous functions out of your JSX and you define them in your component body, that way you have something named that you can go back to. Just anonymous functions in general, I try to stay away from them because when I am profiling the app, it makes it a lot easier to figure out where they are, what's taking so long, and fixing it.
So you can't really necessarily use the fat arrow functions. Instead, you'll be using function and then the name and the function keyword. And you can also make anonymous functions using the function keyword by just not giving it a name, function and then parentheses. But avoid those as well. Sometimes it looks a little weird because sometimes you'll be doing like const my function equals function my function. You're saying it twice.
Yeah.
But hey, it's better to do that and be able to track things down than not.
So what are some tools to use for analyzing performance in React Native apps?
Yeah, I've already talked about a couple of them already. The one I'm using right now is Flipper, Facebook's React Native dev tools sort of thing that they provide and ship with React Native. It's kind of like a Swiss Army knife. It's got all sorts of things, logging, debugging. There's plugins that you can get for MobX State Tree and Redux so that you can modify state on the fly using Flipper. But it includes probably one of the more powerful tools, which is the React Dev Tools in there. It's really great because it's got a button where you can just click and reload the app from Flipper. So you don't have to shake your device or hit Command Control Z or Command R. You just click the button in Flipper and it automatically reloads the Metro bundle. So that's pretty cool. But the React Dev Tools, you can run it by itself in its own app, but it's integrated into Flipper. And so I've been using it there. It has two really awesome tools that I use all the time. The first one is the component tree view, which helps you see the entire hierarchy of your application. And if you've never looked at one of these things, they're pretty gnarly. Like you've got all of these views nested within views, and some of them you don't even know where they're coming from because they're automatically injected by things like React Navigation or some other native modules you're using. Or you'll see like the context a lot if you're using React Context. It just wraps everything automatically in that context so that you can use it. So it helps you like figure out like, why is this object here when it should be over here? And so it just gives you a big tree that you can go through and see what's rendering on the screen and why it's there, where it is in relation to all your other components. And then the Flame Graph Profiler is a really, really great tool where essentially you can start your app and profile it, do something in the app, and then stop profiling. And then it will give you basically a list of how long everything took to render itself and its children. And you can drill into each one and see how many milliseconds it took. And then from there, you can figure out, okay, this component took a long time to render. Where is that coming from and how do I make it faster? The Chrome Dev Tools, the React Dev Tools, which is also available in Chrome, you can run it there as well. Helps a lot for kind of giving you a hit list for each render cycle on what takes the longest so that you can focus your efforts on where you're going to make the most impact in the app. Because if you try and go around and optimize your app by throwing use memo and use callbacks around everything, it's not gonna make it faster. I can tell you that.
We're gonna talk a lot more about that in part 2 because we have a whole section on hooks and how to optimize those.
Yeah, absolutely.
It's gonna be great.
I also found a really cool project called Why Did You Render? It's by a guy on GitHub, Well Done Software. We'll put a link in the notes, but you basically integrate it into your app in dev mode and then turn it on and it will monitor your entire app and tell you every time something re-renders and why. And a lot of times it'll tell you like this thing re-rendered, but it didn't need to because the shallow prop comparison was false or something like that. So Why Did You Render is another sort of tool on the tool belt of the React Native developer. I have it integrated into some of my projects, and it's always off by default because it just generates a ton of console logs. This is another time for using something in a targeted manner. Turn it on when you need it and make sure it's off so that the rest of your team doesn't hate you. But yeah, console log is also a really great way to figure out what's going on. I use console log all the time, but I never really leave it in my code. But just to figure out like what's happening in what order. Sometimes console log is your best friend to just figure that out really quickly so you can fix a bug.
So what you're saying is that console log can both be a fix and a cause for your performance problems.
Yes, it's like alcohol. It's the problem and solution to
Use it wisely. Don't be addicted.
I love it. So Mazen, who couldn't be here for part one here, he had a note about post-processing your project. So there are some things that you can do to improve apps performance after you've kind of like, actually programmed your app. One of them is images. How can you kind of optimize the images that are brought into your project?
Yeah, definitely. You always want to use vector images if at all possible. Like if you're working with a design team and they've got a design for you and they hand you a bunch of bitmaps, that's probably you're probably going to have a bad time. Bitmaps in general take longer to read from disk and render. And if you get an image that's too big from a designer and nobody notices, it's like 4 times the size of the container that it wants to be in. So you're like, oh, I'll just strap resize mode constrain on this image property. Well, that actually is handled on the native side. So it just gives iOS and Android that image container and says, make the resize mode constrain. And it relies on the native part to actually change that image and scale it down. And actually on iOS, that's very, very slow, to be frank. And so whenever you're putting an image in, you should always make sure that your images are sized appropriately for the container that you're putting in. Use thumbnails whenever possible, or maybe even some sort of server-side image size changer. I don't know. I've used those in the past.
Like Cloudinary.
Yeah, exactly. I've used those in the past to like say, I want an image and I want it this size, and it'll return back to me a bitmap that's the proper size for my container. Resizing images down is never really a good idea in React Native because it can, especially in list views and stuff where you generally have a large set of images along the left-hand side or something like that. If you've got every single one of those images is 1,000 pixels by 1,000 pixels and you only need it to display in a 50 pixel box, like that image should be 50 pixels or 50 at 3x. Mm-hmm. So that you can make sure that you're not doing any completely unnecessary re-rendering on the native side for those image sizes.
Yeah, and I found a really cool tool called Expo Optimize, which allows optimizing not just Expo projects, but really any project that has embedded images. And it won't resize things for you. You still need to do that yourself if you want to do that. But it runs through and like compresses your images to a degree that you're not going to necessarily notice it yourself, but it will save you a lot of disk space.
Yeah, definitely. Don't ever trust an image that was given to you by a designer. Like always make sure it's minified, optimized for native, because if you're including these images in your app bundle, those large images are also going to increase your download size. As well. And so part of optimizing is also making sure that your bundle size is small enough that can be downloaded over cellular. Nobody wants to download a 200 megabyte app when they're out and about.
So I purposely left this out of our tools discussion, because I kind of wanted it to have its own section. But Reactitron, which is the desktop app that we use that we built at Infinite Red, actually has some performance benchmarking tools, which is pretty cool. And basically, if you have a function that you think is slow, you can benchmark it, and you can use Reactitron.benchmark. Or if you've hooked it up to console.tron, you can say console.tron.benchmark. And then you just do steps through your code. And then the last one is .stop. And then when you call that, it will actually show you this really cool graph in your Reactitron timeline that is very targeted to the thing you're benchmarking. And so you can actually see, like, it looks like a Gantt chart or something like that, where you have your different things that you're logging out, and it shows you how long they took and sort of a proportion in the bar chart that you're putting out there, execution time. So it's a really cool way to kind of dig into one particular slow function.
Yeah, I can see how that would be a little bit better than why did you render, which basically just spits out everything. You can configure it to just do one thing, but I actually haven't used that in Reactatron. That looks really neat. I'm going to have to give that a try.
Yeah, I'll link to it in the show notes as well. It's something that, I mean, just like everything Reactatron, we don't even promote it well enough internally, what it can do, much less externally. So that's something I just wanted to mention.
Nice.
All right. So I think we're out of time for part 1. We have part 2 coming up. In the meantime, where can people find you online, John Major?
At John Major C.
Mark?
I'm on Instagram and GitHub as Mark Rickert.
And you can find me at Jamin Holmgren. You can also find React Native Radio at React Native RDIO. Thanks, of course, to Mark for joining us today for part 1. He'll also be here for part 2. And as always, thanks to our producer and editor, Todd Worth, our assistant editor and episode release coordinator, Jed Bartoski, our social media coordinator, Missy Warren, and our designer, Justin Husky. Thanks to our sponsor, Infinite Red. Check us out, infinite.red/React Native. Special thanks to all of you for listening today. Make sure to subscribe and come back for part 2. Reminder, we are hiring careers.infinite.red, and we will see you next time.